Hi, everybody, and welcome to today's webinar on deploying fiber networks for multi-dwelling units, otherwise known as MDUs. My name is Kelly, and I'm going to be your host for today's webinar. Before we get started, I'm just going to go over a couple of housekeeping items with you. We will be recording this, and we're going to send it out to you after the webinar in case you have to leave early and want to watch it later on. If you have any questions, please use the question box in your GoToWebinar panel to ask them, and we will leave time at the end of the webinar to get to them. And with that, I'm going to introduce our two speakers today. So we have Nazim Chowdhury. He's Manager of Market Development here at iBwave, who's very much been involved in the launch of our recent FiberPass solution, as well as David Tucker, Solutions Engineering, who has been involved in the fiber market and engineering for the last 13 years with lots of experience to share with you. So welcome to our speakers and welcome to you all. And with that, Nazim, I'm going to hand it over to you to get the webinar started. Thanks.
Yep, sure. Thank you, Kelly. So just a little bit about what we're going to speak about today. So I just want to give a quick overview about what we're going to be focusing on as iBwave as a company. We're also going to talk about best practices when it comes to really deploying these MDU type scenarios. So there's several different types of scenarios that we're going to go through, and we're going to walk you through best practices as well as some specific case studies. And at the end, we're going to finish off the webinar by just giving you a quick demonstration of the solution. So we don't have time to do a full solution demo during this webinar, but we're going to just give you a glimpse of how these solutions really come together. Now, if interested, feel free to contact us and we could schedule a full demo where we could really walk you through all the different steps involved in using our solutions. So for those of you who are familiar with our solution, so at the end of the day, iBwave's key focus is really around accelerating the deployment of in-building wireless and wireline networks, but at the same time providing innovative solutions that are going to guarantee profitability, but also ensure that there's going to be flawless connectivity for all the end users. So for those of you who are familiar with our solutions, we cover all types of venues, whether it's hospitality, enterprise venues, transportation such as subways and tunnels, and large venues such as stadiums, and really bandwidth intensive applications like concert halls and arenas and such. But just so everyone's aware, the focus of today's webinar is really going to be around the MXU environment. So bringing connectivity to multi-dwelling units, so to residential users. So this is going to be the focus of today's webinar. And if you have interest in any of these other topics, again, feel free to contact us and we could schedule appropriate demos for those specific topics. But again, today, the focus on best practices for MDU type scenarios, multi-dwelling units, and for residential services. So that being said, I'm going to pass it along to David, and he's going to walk us through best practices for MDU type scenarios.
Thank you, Nazim. So before we look at particular case studies, I want to start off and introduce some general MDU concepts, starting with the difference between high-rise, mid-rise, and garden. Often the distinction between these is based on the number of floors, but it could also be based on the pathways and spaces available. Oftentimes with a high-rise, you'll have a single riser terminating in riser closets as you move up the building. But you may also see a similar scenario with a mid-rise. You might have a mid-rise with multiple risers coming back to a single closet, or potentially drops that go straight to a single closet in a mid-rise building as well. So we'll look at the difference between those two. Garden style would be your typical apartment complex style development, multiple buildings, 12 to 24 units, all connected with an outside plant distribution network. It's also important to understand the difference between a greenfield and a brownfield environment. So greenfield is new construction. Brownfield is your existing or overbuild MDU style building. And we'll look at the next four concepts in the following slide. Starting with spaces and pathways from the outside plant into the building, you have your F1 feed that would land in a main distribution frame, or MDF, also referred to as the MPOP, or main point of presence. From the MDF up the riser, you would have your F2 distribution cabling terminating in the intermediate distribution frame, IDF, or riser closets. From each riser closet, the drop then distributes out the horizontal to each individual living unit. As you can see, we make this F1, F2, F3 distinction Those are legacy carrier GPON terms that help describe the spaces that exist within a building. As we look at the architecture of a building, the cabling may route in a variety of ways. If in that mid-rise scenario where the drops run from the unit all the way back to a single closet, we refer to that as the direct drop home run solution. You may also have a riser scenario where a single cable routes up the riser and is accessed in each riser closet. This is typical of a spliced-in solution where you would have a high-count bulk cable that would route up with slack for access in each riser closet in each floor. Additionally, you have the satellite distribution solution where each closet has a single cable run that goes back to your MDF. This would be typical of a pre-connectorized scenario where you might have a terminal with a cable stub pre-built from the factory. You would take that terminal into your IDF closet and route that cable down to the MDF to connect into your cabinet in the basement or main floor. Additionally, there's an outdoor facade style deployment where if there's no pathway interior, you may connect your cable to the outside of the building. So that would be a facade deployment. There's various technologies that may be leveraged to provide the connectivity in a FTTX style network. Most typical for the carrier fiber to the home solution is the GPON or gigabit passive optical network. This is typified by having an passive optical splitter that exists between your feed and distribution cabling in the network. For MDUs, we make the distinction between a fiber to the unit and a fiber to the IDF deployment based on where the ONT or optical network terminal is located. If it's in the unit, it's going to be a fiber to the unit deployment, or we could potentially put the ONT in the IDF closet. The ONT is your media converter from your fiber optics to your copper connection. That could be for GPON, it needs to be Cat5, Cat5e or better, but you could have multiple Cat5e runs coming into a closet location where you might terminate into an ONT. The fiber requirement in that scenario is much less, which provides a more cost-effective solution. Along that vein, you also have the G.fast solution. It's similar to a GPON network, but instead of, say, a 4-port multi-porting ONT in the closet, you might use a 16-port card or even a 48-port card. The big advantage to G.fast is you can leverage older existing wiring from Cat3 to station wiring to even existing coax to reach near gig speeds. So there are some potential installation cost savings available there when you're in an older building that lacks the necessary pathways. You may also have an active Ethernet solution or a point-to-point network where instead of the optical splitter, you would substitute the splitter in a GPON network with a active Ethernet switch that may be located in a closet or in the basement MDF location. As GPON is most typical for a fiber to the home solution, we're going to look at some splitter topologies, starting with local convergence. This is more standard in the North American market, where you would have a cabinet location between your F1 and F2 networks, where multiple 1x32 splitters would be housed. More typical in a European style market or a market where you have a single provider would be a distributed split network. Instead of a single 1x32, you may plug 1x8s and 1x4s in series to reach your total 1x32 split. There is a whole lot less cabling required in the F2 network and associated splicing and testing. However, with the distributed split network, you're typically placing all of the splitters on day one, which has a cost factor associated with it. If you are the only provider, then you will be building out your network with all partners anyways. So it would be good to consider the cost impact of a distributed split network. The most flexible variation would be the central switch home run, where every fiber from the unit would track back all the way to the central office or head end. This would also work as a Ethernet style solution, where instead of putting 1x32 splitters in your central office, you could substitute that for plugging directly into switches. Again, most flexible, most future-proof, as you've got a direct fiber from the unit all the way back to the CO. Segmented split would be pushing your 1x32 splitter as far into the network as possible. We'll look at a sample case where this style network was deployed, but this has significant cost savings associated with it as well. A little bit less robust as you're thinning down your feed cabling as much as possible, but significant cost savings available. All right, so now we're going to look at various case studies. The first one is a more modern high-rise, this particular building in Portland, Oregon. This building has several parking garage floors. It also has multiple retail locations on the first floor and an architecture office that occupies the 2nd through 5th floors. And then above that, from the 6th floor all the way up to the 23rd floor is all residential. The first network build for this site was to address the residential portion. It is a relatively newer building, so it had Cat5e runs coming back from each unit to the IDF closet. You can see in the bottom right a picture of that IDF closet. Relatively clean, abundant backboard space. There's access to power the ONTs in this location. And because we had the Cat5e drops, it made sense to load ONTs into the closet location and taking advantage of a quarter of the less required fiber by using the multi-porting functionality of the ONT to serve up to 4 units each. The biggest challenge for this building was the presence of multiple services, from the residential for day one to potential retail customers taking service, the commercial application for the architecture office, as well as the amenity spaces, the building-wide Wi-Fi, as well as several utilities that were managed on network. So having a design solution that is modular in the way that as we need to introduce new technologies, we can come back and layer on those technologies, as well as identify what fiber is available from the initial build is critical for future success at that location. On the flip side to the modern high-rise would be this scenario here, the Paulson Center in Spokane, Washington. This is a very old building that has seen multiple configuration changes, whether each floor being adjusted and walls being torn down to combine units or to subdivide units, as well as a whole second wing built on in the future. This building has seen multiple networks come into it. Currently, there's 8 active networks in the building and several abandoned networks. You can see in the top right corner pictures of the riser closets. That middle picture in the top is actually one of the riser closets. You open the cabinet door and you have hundreds of free hanging communication cables that route from floor to floor. If you look closely in that middle picture on the top right, you can see the 110 blocks actually zip tied to a conduit because of the lack of availability of backboard space. So for this building, pathway creation is critical in terms of getting the network up and running. If we're not able to use those closets, is there another stacked closet that could be utilized? As well as what is the aesthetic impact and cost impact to the builder? A build like this, the building owner would have to contribute to the cost to build out. And so looking at various design methods and deciding between which of those is more opportune for the builder is critical. In New York City, the major carrier addresses these pathway concerns in the older building by utilizing a facade technique to install cabling on the area of the building, whether you're leveraging a riser space interior to run a feed cable up to the roof and placing a splitter cabinet on the roof, or having a splitter cabinet mounted on the exterior of the building on the floor level and route your riser cable up along the exterior, making penetrations in either directly into each unit or into a hallway where you would route down the hallway to serve the units. A variety of options available, but the facade technique is one that has been proven out and been effective for addressing the pathway concerns. Now, the pathway concerns aren't limited to the exterior, but also on the interior as well. So the only space to route drops are down the hallways, but it's required that it is an aesthetic solution to the drop wiring. So whether it's your cable molding solution that we see on the left, or a cable channel that we cover existing wiring on the right, or one of the vendors in quote unquote invisible solutions that are out that would be like a micro cabling solution that adheres to the wall with a UV glue or adhesive backing and sits up in the corner and disappears from eyesight. So various invisible, quote unquote, invisible solutions are being leveraged in New York City to navigate down the hallway. As you can see, with every right angle, every nook and cranny, there's different attachment hardware, different clips required. So understanding the floor layout, the building configuration is critical, and then getting approval from the building owner for the impact is important. Additionally, to minimize the impact to the tenants, a rapid deploy solution is important as well. All right, next we're going to look at a brownfield mid-rise scenario, this one in particular in Seattle. This building is serviced with an aerial drop from existing fiber network, routed to a terminal with drops, routed along the exterior of the building, penetrating into each unit. In this particular building, there is no interior pathway for the drops, so an exterior wrap application had to be applied. We're leveraging a rugged cable type that can be bent and clipped in without attenuation of the fiber, and then gaining access into the unit. Again, there's aesthetic concerns that building owner approval is going to be required before you're able to proceed. So helping them visualize what that's going to look like, and potentially make considerations for having to come back and paint the cabling to match the building exterior may be a requirement as well. And for our final brownfield scenario that we're going to look at, the overbuilding of Berlin, Germany. So in Berlin, over the last half decade, they've seen major infrastructure rebuild following World War II and the fall of the Berlin Wall. And with that is a bearing of the utilities below grade, and accounting for quite a bit of extra conduit that is made available for this kind of overbuild deployment, where the one primary operator has a large-scale overbuild program in place to target all of the residents. In Berlin, most of these residential locations are 6-story MDU buildings. So for such a large-scale deployment, having a standardized solution set, in this case, a distributed split scenario where they'd have a 1x4 splitter in a cabinet in the street, serving a 1x8 splitter terminal in the basement with 4 terminals routing to outlets in the units, makes the most sense for them because they are the primary service provider. They're going to see very high take rates that would justify the expense of putting multiple splitters out in the network in a distributed split architecture. But having a standardized product set and repeatable procedures is going to be critical for the large scale deployment. Also, access to the buildings is limited, so being able to rapidly move from the survey phase to the deployment phase is going to be important. All right, next we're going to look at a greenfield mid-rise scenario, this one in Minneapolis. So typical for a lot of mid-rises, we have a main closet and we have a couple riser closets scattered throughout. The challenge here is the limited space inside of these riser closets. So you can see that you're competing for backboard space with various utilities, and you have a large building with only a few closets, so quite a bit of drop wiring routing back. So managing those drops, as well as what's typical in North America, is the builder will hire low voltage technicians to do the drop placement. Those technicians don't necessarily have experience with the fiber nor an understanding what the limitations are with it. So one of the ways that you can address that issue is to engage the industry and work within your locale and the local low voltage electricians to provide training or to understand the requirements, or with each site engage with them early on. So communication and collaboration is key to the success of those projects. As well as with a greenfield environment, you may not have access to power in the riser closets. So a pre-connectorized cabling solution may be considered, where you can bypass the splicing and plug your terminals in with a pre-connectorized cable. All right, and then we're going to look at a greenfield cottage deployment, this one in the Denver area. This is a unique scenario where the buildings are sized perfectly at 32 units each. So that fits well into our GPON 1:32 splitter ratio. So for this project, we were able to consider what we call a segmented split layout, where you push your 1:32 splitter as far as you can. So we would put a 1:32 splitter in an MDU terminal that would mount on each building, and from there, it's a single fiber drop routing into the unit. In this particular scenario, you've got multiple operators vying for a bulk agreement for the development so that they will be the only provider in the market. So in order to give yourself the best chance of being selected as the provider, being able to help the developer, the property manager, property owner understand the solution, visualize it, and see the value in that network. But then as you engage in the construction phase and the conduit network gets built on the outside plant, that's well in advance of the fiber network going in and the building construction. And then when the buildings finally do come online, it's at about a pace of about one per month, could span a year's time, right? So careful communication and collaboration with the developer, with the construction folks, so you know when the appropriate time to get in and place drops, to connect drops, to mount terminals and activate equipment. Understanding that construction schedule through communicating with the developer builder is going to be critical to success. All right, so we looked at multiple project scenarios of different varieties. A lot of different concerns come up and a lot of different ways to address them, but being flexible, having access to the tools that let us know what solutions are available to us is critical, as well as having an understanding from a project management perspective, the process and all of the tasks within that process, and how you manage time, how you manage cost, how you manage resources to execute on the assigned scope for the work. So next, I'm going to pass it off to Nazem, who's going to introduce the FiberPass tool and show how that tool helps you fulfill many of these tasks, how it supports the process and aid in the engineering construction of an MDU project. Nazem?
Yep, perfect. Thank you, Dave. So Dave just walked us through all these challenges we see in an MDU type environment, and he also kind of walked us through really the process from going from survey all the way to actually the deployment and the construction phases. So during this demonstration, what I really want to focus on, and like I mentioned before, unfortunately we don't have time to go through a full demo, but I really want to show you essentially how these solutions really come together. Now, for this new FiberPass solution that I'm going to give you a quick overview of, this is a solution that we've been working with for the last few years with carriers worldwide, and we're able to see massive time improvements with their actual deployment processes, going down from a number of weeks down to a matter of hours. And through the process that Dave just mentioned a little bit earlier, often cases, what we saw was the issue was in many cases was due to idle times. So we saw all these challenges on site, we saw these design challenges, but at the end of the day, there's always approvals required in between these phases. So in many cases, you think you may have the ideal solution, you met all the challenges, you met all the roadblocks, but then when you come and present it to property management, they may be not very pleased with the aesthetics of that solution. So that takes you back to the drawing board. So the goal of our solution is really to not only increase collaboration between the processes, but increase communication between all the parties involved, and also have the approving members really involved in the initial stages of this process. So if I do have a good solution, have a way to communicate it at the very early stages and even have those approving members engaged in the initial processes so that at the end of the day, you're not going to design a solution that's going to be roadblocked by them. So just to quickly talk to you about our solution, again, our solution has been catered to all the parties involved in this deployment process, and they've actually been modified to really cater the stakeholders involved for each part of that deployment process. So if you think about a surveyor, it makes more sense for them to have something very flexible, have something handheld where they can go and capture as much information as possible. Now, when it comes to reporting, some of the tasks that you don't want to do directly on site, but you may want to do off site, such as creating bill of materials, creating different deliverables for the different parties involved, creating construction documents. This can be all done on our desktop solution, really off site. And we also have a collaboration platform that essentially is capturing all the data that's being designed and surveyed back in the field. So it's continuously capturing all this information. And one thing about our solution you're going to see is it's all going to revolve around digital data. So it's going to be a digital design. And this collaboration platform is essentially extracting all that data and creating and putting together metrics for you to see about each of these projects, the timeline of these projects, and what these venues actually look like. And the last thing I want to mention about this collaboration platform is it takes your design away from just being a typical design, a typical hard copy design. What it focuses around is turning your design into an actual asset. So your designs actually turn into live building replicas where you could essentially layer on different technologies as you go about. So maybe in a week's time, I'm doing a fiber design, but 2 months later, I want to add in additional Wi-Fi services or cellular services or IoT services. So your design becomes a live technology replica of the venue. And this is what I'm going to walk you through as well. Some other components of our platform is, again, we focus on modeling actual components down to their specifications. So we work with all the equipment manufacturers. We make sure that their components are accurately modeled and they're simulated in our solutions as well. So if I have a fiber distribution terminal or if I have a Wi-Fi access point, they're all going to be modeled down to their specification and they should be acting as they would in a real life scenario. And finally, last but not least, we also have a training program to ensure that whoever is using our solution knows what they're trying to accomplish, they know how to use our solution, and they know the technology behind the solution as well. So that being said, I'm going to quickly jump over to a demo. And again, it's going to be a very short demo. I just want to give you a glimpse of how these solutions all come together, but at the same time, how we could lead to a massive process improvement that could take your designs down from taking weeks to amount of hours. Okay, so now when I go through this solution, I want you to kind of think about the spectrum we talked about during the deployment process. And in the initial phases, the first phase may be an actual site survey. And what I'm showing you here, think of it more in terms of a brownfield scenario. So I'm a surveyor, I'm coming to this venue, and it may be the first time I'm actually coming to this venue, and I have no information at all about this venue. So my goal here is I'm going to take out my tablet solution, and I'm going to start capturing all those requirements. So as a surveyor, the first thing I'm going to start looking at is, first of all, addressing all those challenges that Dave actually mentioned through his presentation, but also being able to document those requirements and how we're going to address those challenges in an actual visualizable solution. So the first thing I'm going to do is, as soon as I come in, here I have my tablet. So what you're seeing now is my tablet-based platform. And a key focus is really capturing all my requirements. So it could be all my logistical requirements, the locality of the venue, the client information, and some of the initial requirements of this venue. So all those logistical requirements I want to actually capture. Now you're going to see we have different representations of our venue. So we have an outdoor view. So when it comes to the outdoor view, the goal is to start capturing all the requirements from an outdoor perspective. So we have mapping solutions within this tool that's going to pull your live location, or you could even type in an address. But the goal is to really focus on how I'm going to connect this venue. So how am I going to go from the point of feed to the point of entry of the venue? So am I going to use underground buried ducts? Am I going to use an aerial solution and such? But the goal here is, in this mapping tool, you have a geocoded floor plan that allows you to do automatic distance measurements and such, and really document what's going on in this specific location and how we're going to bring fiber from the point of feed to the actual point of venue. So this was the first view. This was the outdoor view. Now, the next thing we may want to look at is from an inside perspective. So my inside wiring, how am I going to address all these challenges, and how am I going to document these challenges as well? So when it comes to your indoor perspective, in many cases, you may have not much to work with. So we have solutions that allow you to import existing floor plans, start drafting new floor plans directly in your tablet, or even if you have nothing to work with, you could start taking pictures of, let's say, emergency evacuation plans to give you something to reference during your actual site survey process. But again, my goal here is to really document what's going on in my venue. So here you can see what I have here is I came into the venue. The first thing I want to look at are areas of interest. So where my IDF closets are going to be, where my MDF closets are going to be. And I want to make sure I get appropriate addressing as well. So the address numbers, the unit numbers, I want to make sure that I have appropriate addressing. And what the solution does is it really focuses on coordinating your zone types back to each other. So if I have an IDF feeding all these units, they're going to be all color-coded alike. So I have one closet, I see all these units in green, that means that they're actually feeding these venues in green as well. Now, the other thing our solution focuses on is really highlighting all the different requirements we're seeing at that venue. So I may have requirements for core drilling, I may have requirements for conduit placement. So while I'm there on site, I could start defining what I really need to design this venue. So within this page here, you're seeing that we have the ability of starting to document, first of all, our addressing, our conduit placement. But even when it comes to, let's say, a closet, I might want to document exactly what's going on in that closet and show what I plan on doing in this specific environment. So I have a closet, I have enough space, so I want to document that I have enough space and what my equipment is going to look like in that specific space. So again, the key here is what we're focusing on is really understanding what we're going to do at this venue, capturing all the requirements, and also looking at the aesthetical impact that it's going to have to this venue. And one of the key benefits of having a digital solution is you could start the engagement process from the very early phases. So I'm at the venue, I did a preliminary design. Why not go show this to property management right away, get their feedback on it, have them engaged in that process so it doesn't lead to any delays later on. So get them engaged. If they don't like something about your solution, a key benefit is we can make adjustments directly there, have them involved. I could make changes. If they don't like one specific routing, I could change my routing and really have them involved in that process. So one thing here is we're capturing all those requirements, we're communicating those requirements, and the last step is we could collaborate these requirements with somebody who's going to focus on further deliverables. So a key aspect of our solution is how we could communicate back and forth with your field teams to your engineering teams back in the back office. So what I can do next is, as soon as I'm done my survey, I captured all these requirements. And what you're seeing here is I actually have all the intelligence required to further automate my design. I have my closets, I have my pathways, I have the units that I want to feed. So essentially I have all the intelligence required to really automate my design. So I'm going to send this over to my engineering teams. And I'm going to move over to my desktop solution now. So bear with me a second. And what you're seeing here is essentially my desktop solution. So for me now, if I was a designer, so think of me as a designer now, what I'm receiving is basically all the intelligence that was captured in the field. So I see all the living units that need to be connected. I see all the closets. So as a designer, really what I could focus on now is putting in the finer details to my design, such as what kind of equipment I want to use, what kind of if I'm building a cabinet, what do I want to place inside that cabinet? What kind of fiber counts do I need? What kind of fiber lengths do I need? So I have all the information to be able to really automate my design. So as a designer, my job just got much easier now. So essentially I could really connect up my system, see it from different perspectives. I could see what my riser view may look like with all my cables connected and all my living units connected as well. And what I can also do is I could really get different perspectives. So an optional feature in our solution is if you start drafting in our solution, you have the ability of starting to visualize your venue in a 3-dimensional format as well. So I have my venue here. I could see what it looks like, and I could even break down inside it. So if I wanted to, I could start walking through the venue. I could, let's say I could see it from different perspectives. I could come from the front. I can walk through the venue. I could see equipment placement inside those venues, and I could see it from different perspectives. So if I want to see it from the top, and I really want to focus on what the backbone of my design looks like, I could see different representations of what my design is going to look like. Now, again, a key aspect of our solution is really automating deliverables at the right time. So in order to cut down idle times, a key aspect is making sure you have the deliverables at the right time. So I completed my survey, I had the right deliverables to present to property management. I finalized my detailed design, and now I could create multiple different deliverables. So just to show you a sample of an automated design package, what I can do is I could take my desktop tool and start creating automated deliverables. So what you see here is just an example of one of these automated deliverables that you can generate. It's going to take all your requirements. It's going to show you your addressing. So what closets are feeding which units are getting service, how much conduit requirements or microduct requirements you're going to need to feed each and every one of these units. And what you could also do is you could start making different cost analysis. So if I'm looking at specific equipment manufacturer and I have specific pricing for them, I could ingest them in the tool to give me a good understanding of different pricing requirements for different solutions. So here you can see it takes all my bill of materials. I could associate and quantify pricing for those equipments and get a good overview of what this solution may actually end up costing. And again, it's going to pull in all your requirements. And when it comes to collaboration, so what you're seeing here is these reports are actually consolidating all the information from the very start. So in the very beginning, I started capturing different requirements. I started capturing different photos, but this is being embedded in the software. As I start creating these deliverables, they start appearing again. So what I want to do in these closets, what I want to do in the riser, what I want to do in the MDF, what I want to do in the IDF. So really creating these automated packages. And creating these automated packages at the right time was really what allowed us to essentially cut down a long deployment cycle into a matter of hours, which we spoke about previously. Now, the other point I want to quickly mention was what I showed you here, these reports that I just generated. This is not really the end outcome of the solution. Really what we're focusing on is we want to move away from just creating hard copy designs and really turning your designs into actual assets. So what I spoke about previously is we have this Unity platform, and what this Unity platform does is it essentially is compiling all the data that it's seeing from the field surveys, from the design tools, and it's focusing around creating an actual building hub. So for all these buildings I design, whatever technology it may be, it's going to start generating in this Unity platform. So at any point in time, I could see exactly what's going on inside any of these venues. So I could open up this venue, I could see what's going on inside this venue, I could see all the equipment that's been placed, and essentially it becomes a live replica of that venue. And since it's a live replica, essentially what it allows you to do is, for those of you who are familiar with our other solutions, you have the ability of opening up your designs in any of our other solutions. So if you want to do a Wi-Fi design, you can open up this building, layer on a Wi-Fi solution, or layer on an IoT solution, or even layer on a cellular solution. So it really focuses on turning your building into going away from a design into an actual asset, a live replica of the actual building. And the other point I was making previously was that essentially, since you're moving over to digital design, at the end of the day, every single line, every single item we drop in our design tool becomes a data point. So everything here, this is a digital design, everything is actual data point. And having a platform, a collaboration platform, allows you to essentially crunch all that data you see in your design to create different valuable business intelligence or different metrics. So what I want to show you here is how you could start manipulating that data you see in your design just to create different perspectives. So if I want to see the number of homes passed I have per city, or if I want to see the number of technology I have per building, I could start seeing that data. And these metrics are being populated automatically as your workforce is currently working on their projects. And these are just some example metrics. So if you want to see your cost analysis, so estimated costs per project, you want to see number of homes passed, number of technologies per project, and such. So these are just example metrics, but at the end of the day, the point I was getting to is everything in your design is data, and you could manipulate it in different ways to create different intelligence for your needs. And the last topic I want to talk about was essentially what I was mentioning before. And even Dave was alluding to it in his presentation as well, how in often cases there's going to be a need for multi-technology designs and how you could address multi-technology scenarios. So in some cases you're coming into MDUs and there's going to be businesses on the bottom floors, and you may want to start adding on different technologies. So these businesses, they may not only need fiber, but they may need Wi-Fi access points, or they may need cellular connectivity so all their workers could have access to the wireless network as well. Or it could be that there's security requirements or IoT devices. So again, the goal of turning your design into an asset is to be able to keep layering on these technologies as you see fit. So day one, I brought in my fiber. Day two, I added my wireless services. Day three, I added Wi-Fi services. I added cellular, I added IoT, I added smart devices. But at the end of the day, it really reduces the need of continuously having to do a site survey for all these individual technologies, because I have a live replica of the venue. I know what technology is already in there. I know what kind of fiber I have in there. I know what kind of fiber I could reuse. I know how much space I have in my closet. So I don't need to do an additional survey. I could just quickly start layering on these different technologies. And again, focusing around your building really being a live technology replica of your venue. So again, this was just a really high-level overview of our solutions. Again, if you're interested in learning more about any of our solutions, feel free to contact us and we could schedule an appropriate demo to really go into details of how these solutions come together and how we could really focus on process improvement and cutting down weeks into a matter of hours.
Thanks, Nazim. So I think that concludes then our educational and demo portion of the webinar, so we can move into some questions for the next 10 minutes or so. So the first question, Nazim, I think this one's for you, is the new iBwave FiberPass a separate software from iBwave Design?
Yes, so the answer to that question is yes. But one thing I want to point out again is that even though these are separate platforms, kind of addressing separate requirements. So here we're talking about how we're addressing MDU scenarios. At the end of the day, our file formats are cross-compatible with all our solutions. So what I'm showing you here is, first of all, I designed an MDU solution, but then I opened it up in my wireless solution where I started to add on different layers of technology, and I started doing propagation scenarios to see that I have the appropriate end user experience as well. So while they are different platforms, at the end of the day, the file format is cross-compatible to each other. So regardless of what solution I start with, I could bring it into the other solution as well.
Okay, thank you. This one question is, can you do actual fiber network design to include link budgets, band attenuation, WDM, etc.?
So yes, absolutely. So in our solutions, you're going to see you have all these specific features to help you with your design, whether it be for link budgets and such. So if you want a more detailed demonstration of these topics, again, you could contact us and we could go through those in details as well.
Okay. David, this one's for you. What about use of single mode versus multi-mode and future proofing even if the distance is under 1,000 feet?
Sure. So what's typical for a fiber to the X, fiber to the home deployment is the use of single mode fiber. You know, FTTX is typically an outside plant deployment with longer distances The multi-mode fiber solution just doesn't allow you to propagate your signal far enough without dispersion. So you have to go with a single mode in the outside plant. Because MDU deployment, residential deployment, stems off of that legacy carrier fiber to the home deployment, they've carried their single mode fiber into the building. The equipment that's being developed, the electronics that's being developed to support, has a lot of that in mind, right? So these larger carriers around the country, around the world, have the buying power to push the innovation on the electronic side, but then to also make those electronics more affordable. If you look at the flip side, typical enterprise local area network environment, usually that's a multi-mode style network. The electronics associated with multi-mode are a lot less expensive. They're able to use LED light sources as opposed to lasers. And so the electronics historically were less costly for a multi-mode style network, but you're seeing that shift, and you're seeing the equipment more geared towards a single mode deployment in these MDUs. So it's certainly worth evaluating what technology do you want to deploy. If you're going to deploy an Ethernet solution, maybe you want to run two multi-mode fibers to each unit. But if you're servicing a larger area, if you're a small operator and you want to invest in GPON technology, then you're going to have to leverage single mode fiber.
Okay, great. Thank you. Nazim, this one's for you. Can you upload models into FiberPass, or do you have to create them within the software?
Yeah, so depending on the native format of your model, so in iBwave Design, you could pull in image files, you could pull in AutoCAD files, and again, you could start working on it from there on. So you have the ability of uploading different types of formats, and it really depends on the format you're working with. But if it's an image file, a PDF, or an AutoCAD file, you could ingest them in the tool as well.
Okay. This question is, will there be changes to iBwave for more efficient fiber design?
Yep, so some of the features you see here, and I kind of talked about it in this webinar, it focuses a lot around automation. So we have some of the intelligence we brought into the field, but we focused on making fiber design much more simpler. So for those of you already familiar with our iBwave design platforms, previously we didn't have what we called this cable automation tool. So this cable automation tool really helps you connect up all your requirements. So your fiber, where it's the source point of that fiber and where it's actually going to terminate. Additionally to that cable automation tool that we created, we also created a riser element that allows you to feed your fibers into that riser and direct them all to the appropriate floor. So we added these functionalities to make riser designs much more simplified in our design tools.
Okay, great, thank you. So Dave, this one is for you. What fiber type is best for MDUs?
Yeah, so that goes back to the first question. Again, the technology being developed to support MDU applications from a carrier perspective are being geared more towards single mode. So that would be my default answer. But certainly if you as an operator are more experienced with a local area style network, indoor networks using multi-mode fiber, and you're able to provide the service packages over Ethernet style deployment, and it's just a data package, then certainly it would be worth evaluating the multi-mode fiber type as your cabling solution.
Okay, that was actually a three-part question. So the second part is, how do you determine the number of strands of fiber for deployment? Yeah,
so with the GPON network, we saw that we're deploying optical network splitters. That would potentially change the amount of fiber you need in your F1 segment, your F2 segment, F3. Standard for a GPON network is a 1/32 split. So from that splitter location, it's a 1-to-1 fiber ratio for GPON. So your single mode fiber has both transmit and receive capabilities. So it's working in both directions at the same time. So it's one fiber per unit for GPON application on the distribution side. And then when you get into the feed, your requirement really is only based on the ratio 1 to 32. Certainly smart to upsize your feeder though. If you're going with a multi-mode network or Ethernet network, you may need 2 fibers per unit for transmit and receive. So first thing to do is understand what electronics you intend to use for your network, and then that'll drive how much fiber you want to use. And then the fiber size in a distributed split network is a little tricky, but it's good to know 1x4 splitter, 1x8 splitter, and what's that ratio impact going to be to the cable downstream.
Okay, and the third part was, how do you determine which connector to use?
For GPON, the standard connector type is the SC APC, so it's that green angled polish SC style connector. But I think if you're not doing GPON, what's important to consider is having a field installable connector for connecting drops or making necessary repairs. So when you design your network, SCs are going to be typical. You could go with a small form factor to reduce size of housing. So that might be like an LC style connector. But I would ensure that you've got an option to do a field installable version of that connector if needed.
Okay. This question is, can we connect more than 32 splitters at the final building location?
So if you are operating over a GPON network, which it seems like that's the assumption, and you've got a 1x32 splitter, what happens when you have a 33rd customer? You have to add an additional splitter, which would mean you would need an extra feeder fiber servicing that splitter, and you'd also need an extra port on your OLT back at the central office or head end.
Okay. Nazim, this one's for you. What options does FiberPass have that iBwave does not? If you give kind of just a summary of what the differences might be.
Yeah, so the key point I want to point out is in our FiberPass platform, you're going to see how it really focuses on collaborating between what's happening on site and what's happening in the field. So like I showed in the demo, you really focus on getting all the intelligence required. And in the design tool, that intelligence is used to kind of automate your design. So it kind of varies from the traditional process that our existing iBwave design users are focused on, which is really optimizing levels of service. Here you're focusing on several different variables. So what you're hearing from property management, what their aesthetical impacts are, what the aesthetical impact is going to be for them, their level of approval. So really being able to communicate that information directly on site through a tablet-based platform, and being able to automatically communicate that to designers. So it focuses a lot on both tools working kind of hand in hand, especially for a brownfield scenario. Now, in a greenfield scenario, again, it could be vice versa, where you start your design directly on your desktop solution, but in your tablet solution, this is where you could verify once the building is up that this is actually a feasible design. These conduits that were in my existing CAD files are actually in those right locations and such. So in terms of the differences in this tool, so it really focuses, this FiberPass tool really focuses around fiber components, fiber elements, and how to connect them, how to properly connect them in a more automated fashion while still looking at aspects such as who are the users, where are my termination points, where are my closets as key focuses, as opposed to some of our other solutions. Aside from that, what's also important is how we also focus on a much more outdoor perspective as well, because at the end of the day, we want to know how we're going to bring our fiber from the point of feed, what kind of construction is going to be required from that, from our outdoor scenario as well, not only in our indoor scenario.
Okay, great. Another question somewhat similar along the same lines is, do you need different platforms for different solutions, or is it one platform for different solutions?
So the Unity platform, so we have the Unity platform, which allows you to tie in any of your additional platforms. So I have Unity, then I could have a FiberPass design. I could have my FiberPass solution that ties into it. I could have my wireless solution that ties into it. But these are different modules. So and they have different focuses as well. So if I'm focusing on bringing fiber to these residential customers, I would more use my FiberPass design tool. If I'm looking at a large venue where I want to put in a DAS, such as a stadium, then I'd focus on more using my iBwave Design Enterprise solution. And if I'm focusing on more just adding Wi-Fi solutions, then we also have Wi-Fi solutions as well. So we have different platforms, and they cater more towards your end user requirements.
Okay, makes sense. And one question here is, must Unity be used to import, export to and from FiberPass and iBwave Design?
Yes, and the reason behind that is Unity is actually key to enable the collaboration between the two parties. So if you look at the traditional process, this is a lot of where the time savings comes into hand. So looking back at the traditional process, you may come to a venue, you might start doing a site survey. It could be on paper and pen. And in often cases, it may not be the site survey that takes a lot of time, but it's really translating that site survey into actual documentation that takes time. And in many cases, I may be doing 10, 15, I may be doing like 10 surveys in a day. And in some cases, you kind of get lost with regards to remembering what is this photo of, what venue is it of. So there's a lot of time associated to compiling those surveys. And our goal is to really automate those deliverables instead of having to compile it afterwards. Now, not only is automating those deliverables important, but collaborating it with the different teams is just as important. So as soon as I'm done my site survey, my goal is to cut out all the idle time. So I create deliverables for property management right away, but at the same time, I'm sending my information directly to a designer who could essentially start working on it right away if it's a different party involved. So Unity is key to enable this collaboration between the end users.
Okay, great. So that concludes our question section, and with that, we conclude our webinar. So a big thank you to both David and Nazim for presenting today, and a bigger thank you to everyone who joined us for the webinar. Again, it was recorded, so I will be sending out a copy to everyone. Thank you again, and have a great day.
Thank you, everyone.